Welcome to today's deep dive. We are so glad you could join us today.
Absolutely. Glad to be here.
Today we're opening up a stack of sources that feels, well, it feels almost alchemical.
Oh, that's a good word for it. It really is.
Yeah, we've got this fascinating, incredibly dense collection of mathematical and philosophical notes. They're by the author David Ciorizzi, or Dado,
Right.
and the mission for this deep dive is it's completely mind-bending. We are going to unpack something called logospheric arithmetic.
It's a radical reimagining of mathematics.
Totally.
Because in classical math, the kind you and I learned in school, right?
Sure, yeah. With the chalkboards and the textbooks.
Exactly. We're taught to think of numbers as static symbols. Like they're just rigid little tools we use for counting apples or, measuring distances.
Right.
But in these notes, numbers are alive.
They're alive.
Yes. They're living, breathing nodes of symmetry and rhythm. We are going to explore how mathematics can literally be rebuilt from the void up without relying on any of those static rules.
And we really want to show you how this transforms incredibly abstract concepts into this vibrant, multidimensional reality.
It's beautiful, really.
It is. Now, you might be thinking, I'm not a math genius. Is this for me?
Right. People hear math and they run.
Exactly. But trust me, it absolutely is for you. We are going to translate all the heavy formulas into ideas you can actually visualize.
No calculators required.
None. Even if you haven't touched one in years, this deep dive is going to offer you a profound aha moment about the hidden, beautiful structures underlying reality itself.
It completely changes how you see the world.
Okay, let's unpack this, starting with the Pythagorean theorem.
Yes, Pythagoras. When you think of that name, you probably instantly picture a right triangle.
A squared plus b squared equals c squared.
Exactly. You think of a flat surface, straight lines, rulers.
Yep.
But Ciorizzi's notes derive this exact same theorem without ever drawing a triangle.
Which is wild.
Or using coordinates, or even using traditional numbers at all. It starts from absolute nothingness, or rather, the interaction of abstract entities that the notes simply call somethings.
Wait, hold on. Explain that to me.
Okay.
How do you get a geometric theorem from abstract somethings without drawing any lines? Because the notes refer to these entities as C and F, right? But what are they actually doing?
Well, think of them as pure concepts or phases, rather than fixed quantities.
Okay.
The whole system kicks off the moment you establish a relationship between them.
Like a ratio.
Exactly. K equals C over F.
Yeah.
It creates a basic ratio, a connection between two pure ideas.
Right.
And from there, the system moves into an iteration. Instead of just adding 1 plus 1, each new something is born from the past through a shared phase.
So it's an equation C sub n equals K times F minus C sub n minus 1.
Yes. But conceptually, it's not just a static list of numbers.
Right.
Imagine a pendulum swinging.
Okay, I can picture that.
The new position of the pendulum isn't just a random spot in the air. It relies entirely on its momentum from a moment ago, pulled by gravity. Ciorizzi's math does this with pure concepts.
The next entity in the sequence is born by pulling from the shared phase of the previous one.
Precisely. It is a dynamic birth of a sequence.
Wow. Okay, I can picture that swinging momentum, and then the notes introduce what the author calls a mirror involution.
Yes. A hat equals 1 minus B hat.
Which sounds incredibly technical, but if I'm reading this correctly, it's just the idea of two things perfectly complementing each other to make a whole, like a lock and a key.
Or a physical reflection.
Right.
That is a perfect way to put it. You abstract this relationship into a simple idea of a mirror reflection. And out of that pure, abstract mirror relationship, the famous orthogonal harmonic relation naturally drops out.
Just like magic.
The math aligns to show that one squared phase plus another squared phase equals a third squared phase. A hat squared plus B hat squared equals C hat squared.
You get the Pythagorean theorem completely built from the void. You know, when I first read the fruit geometry section in the notes explaining this, I actually had to laugh.
It's quite the analogy.
Deriving Pythagoras from apples and pears, it sounds like a surrealist painting. But then you look at how the author visualizes it, and suddenly it clicks.
It really does.
So for you listening, imagine you are looking at a grid. On this grid, we have apples, which represent our first phase.
The A hat.
Right? And pears, representing our second phase, the B hat.
And imagine these fruits moving as dynamic trajectories across that grid.
Yeah.
Because of that mirror involution, that lock and key relation we just talked about, their phase forces automatically combine.
They are pulled together by a new resonant attractor,
Yes, and the notes playfully call this the cherry.
the cherry. So if you square the phase force of the apples,
And you square the phase force of the pears.
they combine perfectly to create the square of the cherry.
Yeah.
Apples squared plus pears squared equals cherry squared.
It's brilliant because there are no rulers involved.
Hmm.
No protractors measuring 90-degree angles.
It's just pure harmonious resonance pulling these concepts together.
And we shouldn't limit this visualization to a flat grid either. The notes make a crucial point that the true home of this Pythagorean harmony isn't a flat piece of paper.
Right, it's a sphere.
It is a sphere, where the formula transforms into cosine C equals cosine A times cosine B.
That spherical projection is such a beautiful image. How does the apple and pear metaphor work when you wrap it around a globe?
Well, when you move this concept to a spherical surface, it's no longer about measuring straight lines on a flat plane. It becomes about the projection of phases from a center point, that original void, outward onto the surface of the sphere.
Oh, wow.
The angles are created by how these forces project and curve. It proves that the Pythagorean harmony is an effect of interacting symmetries and curvatures in space, rather than just some arbitrary rule we invented for flat geometry.
That feels so much more organic. But to understand how these phases actually move and interact, whether on a grid or a sphere, we really have to look at the rhythm driving them.
We do.
And that brings us to the foundational act of this entire framework. The notes say it all starts with the primal act of the number 1 looking at 0.
Yes, the origin story of this arithmetic.
Okay.
In Tsirinski's framework, numbers aren't just sitting in a pile waiting to be counted. The very act of the singular unified 1 gazing at the empty void of 0 instantly creates two distinct modalities.
Wait, hold on.
Yeah.
If 1 is just looking at 0, wouldn't you just have a 1 and a 0? How do you get modalities out of empty space?
That's the mental leap here. It actually gives birth to the concepts of 2 and 3.
Just from looking.
Yes, the gaze itself creates a reflection, a duality. That duality is 2, which represents the mirror, symmetry, and strict binary control.
Okay, the 2 is control.
But simultaneously, the interaction between the 1, the 0, and the reflection creates a dynamic flow. That is 3, which represents the cycle, the dynamic movement, and life itself.
Wow.
They don't just happen to meet later down the number line. They are born together in that very first act of distinction.
Okay, so you have the strict control of the 2 and the dynamic living cycle of the 3. And when these two forces interact, they create something the notes call the theorem of the hexadic rhythm.
Which is essentially the pulse of reality.
The pulse of reality. Let's walk through the mechanics of that pulse.
We now have a tripolar system because of the 3. So we have 3 elements.
Right.
And each of those elements can exist in 2 states because of the 2.
Mm-hmm.
Let's just call those states positive and negative.
Okay, positive and negative.
If you want every single element to experience every single state, you have to make exactly 6 mandatory moves. 2 times 3 is 6.
Which creates a 6-beat cycle.
Yeah, it's known as the hexad.
But the cycle isn't finished at 6, is it? Because if you just stopped at 6, you haven't returned home to where you started.
Precisely. You need to close the loop.
Right.
To return to the original starting phase,
Mm-hmm.
without breaking the symmetry or the positive volume of the whole system, you need additional steps. The math dictates you need exactly 2 compensating moves.
So 6 plus 2.
Exactly. You have your 6 mandatory moves plus 2 compensating moves, which equals 8. This 8-beat cycle is the minimal pattern of existence for any stable system.
And for you listening, this isn't just some clever math trick happening in a vacuum. This rhythm explains why we see these specific numbers echoed everywhere in our physical world and our human history. It is the underlying architecture of stability. Think about the 8 trigrams in the ancient I Ching, or the 8 notes that make up a musical octave. The universe vibrates on this hexadic rhythm of 6 plus 2.
What's fascinating here is that this hexadic rhythm exists implicitly even within the number 1 itself.
Really, inside the 1.
Yes. The notes refer to this as the omega sub-zero point.
Ah.
Even before the 1 splits into 2 and 3, the potential for those 6 moves and 8 phases is already coiled up inside it, like the genetic code inside a seed waiting to bloom.
So if this 8-beat pulse is the foundation of everything stable, how does that apply to the most famously unstable, unpredictable things in math?
You mean prime numbers?
I'm absolutely talking about prime numbers.
That is exactly where this framework shines. Classical math defines a prime number very dryly. It's just a number greater than 1 that is only divisible by 1 in itself.
Right. Classical math treats primes like these weird, random, unbreakable rocks scattered haphazardly along the number line. There's no apparent pattern to where you find them.
Not at all in classical theory.
But logospheric arithmetic completely redefines what they are.
In this new paradigm, primes are defined as the stable logos of the number stream.
Stable logo.
Yes, they are the resonant nodes in that hexadic wave we just discussed. Because the fundamental pulse of numbers operates on a period of 6, almost all prime numbers naturally fall onto 2 active rays.
Active rays. What does an active ray look like in this context?
Imagine the 6-beat rhythm as a strong central current in a river. The active rays are the channels flowing immediately on either side of that current.
Right.
Mathematically, they sit at the positions just 1 step before the 6-beat pulse and 1 step after it. 6K minus 1 and 6K plus 1.
Right.
Because they sit right on the edge of that foundational rhythm, they hold the resonance perfectly.
This means primes aren't random at all. They are standing waves of harmony.
Yes.
And the visual metaphor the notes use for this is absolutely stunning. It is called the hexagon prime flower.
It's incredible.
Okay.
If you map out the numbers using a logarithmic radius, essentially drawing them outward in expanding circles,
Okay.
and you set the number 5 as the center point, something incredible happens.
Let me make sure I'm painting the right picture for the listener. Why start with 5 in the center?
Because in this specific rhythm, 5 acts as the natural phase 0, where the forces of 2 and 3 first deeply intertwine.
Ah, I see.
When you anchor the map there and spiral the numbers outward, the primes start to form a very specific pattern called a Fermat spiral.
Which, if you look at it in nature, looks exactly like the arrangement of seeds in the center of a sunflower.
Exactly like a sunflower.
The primes aren't scattered blindly. They are forming gorgeous arcs, bands of density, perfect natural spirals. They are the living nodes where the dynamic flow of the 3 perfectly balances with the dividing binary control of the 2.
Which naturally gives us a totally new way to look at composite numbers.
Right, the non-primes.
Right. In classical math, a composite number is just a number you can divide by something else, like 4 or 9. But in this framework, composite numbers are broken resonances.
Broken resonances. That sounds almost tragic.
It is a structural collapse. A composite number is a point in the flow where the dynamic living cycle of the 3 is overwhelmed and destroyed by the binary dyadic control of the 2.
So the harmony fails?
The harmony fails, and the standing wave collapses into static.
So the primes are the pure notes ringing out clearly, and the composites are the static breaking up the signal.
Perfectly said.
And if these prime numbers are ringing out, there has to be an acoustic center they are ringing from. Here's where it gets really interesting. Let's introduce omega.
Yes. Omega, represented by the Greek letter. And we need to be very clear here. Omega is not the number 0.
Right. Classical 0 is just a placeholder on a ruler. It just means nothing is here. But omega is totally different.
Omega is the imaginary center of the number line. It is the ontological condition that makes counting possible in the first place.
Because it functions as a true center point.
Exactly. It exists at the intersection of 2 binary axes. Imagine a 4-way intersection. You have the axis of direction. Are you moving towards omega or away from it?
Okay.
And you have the axis of side. Are you on the left side of omega or the right side?
Okay, let me make sure I'm visualizing this right for our listener. You're saying omega isn't just a static 0 on a ruler. It's more like a prism that changes the light as it passes through.
That is a brilliant way to picture it. And because you have those 2 axes towards and away, left and right, omega acts as a prism with 4 distinct phase states.
Plus, minus, plus, plus, minus, and minus, and minus, plus.
Yes. Mathematically, this forms what is known as a Klein group, which is a perfectly symmetrical structure of 4 interacting states. As you count, as you conceptually move back and forth across the number stream, you are constantly passing through these 4 phases of omega.
The notes literally contain a section called the Revelation of Omega, and it reads almost like an ancient warning.
It really does.
It says that if you try to insert a classical 1 or a 0 directly into omega, if you treat it like just another normal number on a ruler, you kill the symmetry.
You destroy the return path.
Yes, you leave the entire sequence dead, linear, and blind. Omega has to remain the invisible mirror that inverts the signs as the count passes through it.
It forces us to realize a hard truth about how we've been taught math. Classical arithmetic, with its static 0 and linear counting, is just a frozen, dead slice of reality.
So it's a dead slice.
Logospheric arithmetic treats counting as a dance of phases. You weren't just accumulating quantities in a straight line, you were dancing back and forth through the living prism of omega.
A dance of phases. I love that. But if you needed hard proof that this dance is real and not just philosophy, The notes include a literal computer experiment.
Oh, the Python script.
Yes, an algorithm written in Python designed to test this exact theory. They called the experiment enhancing the three.
The premise of the algorithm is beautifully simple but brutal.
What does the script actually do?
It follows one strict rule. If a number is composite, if it is one of those broken resonances we talked about, it gets flattened down into a 1.
It just erases it.
It is erased from the dynamic flow. The system only remembers and retains the primes.
So it's actively weeding out the static. And the results of this Python script are absolutely astonishing. I mean, what happens when you let this run?
The algorithm simulates generations of numbers interacting strictly under these ontological rules. By the time it reaches generation 7, the system achieves 99.9% purity in the allowed prime classes.
99.9%. It almost completely filters out the noise.
Yes, and it does so with a highly specific structural measurement, an entropy of exactly 3.009 bits. To put it simply, without using heavy jargon, it means the algorithm successfully purifies the number stream, leaving behind a hyper-organized, deeply stable structure.
The author's reaction in the notes when the script spits out those numbers is pure joy. He writes, "The Gauss-Euler dog is dead."
It is a massive statement. Carl Friedrich Gauss and Leonhard Euler were two of the most brilliant mathematicians in history.
Legends, really.
But the classical theory they helped cement suggests that prime numbers are distributed somewhat randomly, or at least highly unpredictably, thinning out as numbers get larger.
But this experiment upends that entirely. Under these new rules where composites are flattened and primes are treated as pure resonant nodes, the primes reveal a deeply structured harmony. They aren't random at all. They are the architectural pillars holding up the entire system.
Which brings us to the rigorous climax of Sierzi's work.
Right.
It is one thing for us to use metaphors like sunflowers, apples, and dancing through prisms. But for this to be true mathematics, how does it work as pure, unadulterated logic?
Without the metaphors.
Without the metaphors. For that, the notes introduce a concept called the Omega Judge.
The Omega Judge. It sounds like a character from a sci-fi novel, but it is actually the most elegant part of the whole theory. How does the judge work?
To understand the judge, we have to look at the geometric construct behind it. Every number generates what is called a phase platform, theta sub n.
Okay.
Think of it as a set of points distributed around a circle. And the length of that circle's boundary is tied directly to that foundational 6-beat rhythm we discussed earlier.
Okay, so we have points spaced out around a circle.
Now, on this circle, there's a strict living distance threshold, epsilon sub n. What is remarkable is that this threshold isn't arbitrary. It is defined purely by fundamental constants of nature, specifically pi and Euler's number E.
Think of the Omega Judge like a bouncer at a very exclusive club, but the club is this circle.
A bouncer?
Yeah. The bouncer only has one rule personal space. You have all these points, these phases, standing around the circle, and the bouncer has this exact distance threshold defined by pi.
Exactly. The autonomous test is incredibly straightforward. The judge simply checks the distance between the phases on that circle.
Okay.
If any pair of phases gets too close to each other, meaning the distance between them shrinks below that specific threshold, the symmetry is broken.
The bouncer kicks them out.
The bouncer kicks them out. The number is composite.
But if everyone maintains their perfect distance and all the phases are comfortably spaced out beyond that threshold, boom, they are prime.
As the notes say, one look is enough.
One look is enough.
If we connect this to the bigger picture, the implications are staggering. This entirely eliminates the need for division to find prime numbers.
That's huge.
You don't need to run a number through a massive list of previous primes to see if it divides evenly. It provides a self-contained, purely geometric proof of a number's nature.
Wow.
It proves that being prime is an intrinsic spatial property, a matter of personal space on that circle, not just an arithmetic accident.
It is absolute genius, no division, no calculators, just a single geometric check of distances. So to recap this incredible journey you've been on with us today, we started with abstract apples and pears colliding on a grid to build the Pythagorean theorem out of the void.
We did.
We discovered the 8-beat pulse of the hexadic rhythm that acts as the foundation of stability. We saw prime numbers blooming like Fermat spirals in a sunflower, proving they aren't random.
Yeah, we met Omega.
We met Omega, the living prism at the center of mathematics, and we watched the Omega Judge filter out the static using pure geometry.
It requires a profound shift in perspective to take all of this in.
It really does. And the core takeaway for you listening right now is this. Mathematics isn't just a rigid set of rules you were forced to memorize from a textbook. It is not a dead language of static symbols. It is a dynamic, living architecture of symmetries, standing waves, and resonances.
Yes.
It is the underlying heartbeat of the universe, and we are just now learning how to truly listen to it.
And as we learn to listen, it raises a final provocative thought. Throughout this discussion, we've seen how the abstract world of numbers behaves exactly like a physical space of standing waves and dynamic symmetries.
Right.
We see fractions like 1/3 and 2/3 naturally emerging from the tension of that Hexadic rhythm. This raises a massive question. What if this isn't just a clever mathematical analogy?
What do you mean?
Well, in quantum physics, the fundamental particles of our universe, like quarks, the things that make up protons and neutrons,
Yeah.
they have fractional charges of exactly 1/3 and 2/3.
Oh my God.
Could it be that the physical particles that make up you, me, and the stars aren't just described by math, but are actually the physical shadows of these exact same prime number resonances? Are we literally made of logospheric arithmetic?
Wow. Are we physically made of logospheric arithmetic? That is an incredible thought to leave on. Thank you so much for joining us on this deep dive. Keep looking for the hidden structures in your world and keep questioning everything. We'll catch you next time.